Right. We have talked about the ionizing radiation last week. So let's go to non-ionizing radiation. So it's a radiation in the electromagnetic spectrum which does not produce any positive or negative ion because they do not have enough energy to cause ionizations. Like, for example, the very low frequency wave, like radio, microwave, okay, infrared, visible light, okay, ultraviolet. But ultraviolet, part of it, very high intensity ultraviolet might be the ionizing radiation. So these are the examples, okay? All right, jot this down. Can you understand? So it means that it does not have enough energy. Those radiation does not have enough energy to, to ionize the particle to become positive or negatively charged. Okay? All right, jot this down. Yeah, just right only. Because later on I will give you a comparison diagram, the Jadwal like comparison one. Okay, done. Very done, huh? Okay, so let's see. So ionizing we have already mentioned. Okay, now let's see the difference between the ionizing radiation and non-ionizing radiation. So for non-ionizing, okay, these are the symbol. The symbol is different. This one looks like a fan blade. This one looks like a signal. So there has a low frequency electromagnetic radiation and it has not sufficient energy to ionize the particle. For example, infrared, microwave, and radio wave. While for ionizing radiation, okay, it makes up of high frequency electromagnetic radiation, okay, high energy particle, and it has sufficient energy to ionize particle like alpha, beta, and gamma. or also X-ray. Okay, right, just this down. Then let me know. OK，所以我们来看看下一个部分。所以我们来看看 characteristic of radiative radiation. So alpha is made up of helium nucleus，它就是 helium 的 nucleus，它是 positively charged with high ionizing power。beta 是 high speed electron，OK，、它是 negative charge，然后它的那个 ionizing power 是 moderate。For gamma 呢，它是 neutral，OK，、它是 made up of electromagnetic wave。low ionizing power，OK，but、in terms of 那个叫做 penetration，因为它是 low，它的 ionizing power 比较低，反而它有比较高的 penetration，OK，then、follow by beta，它的 penetration power 最低的就是 alpha，alpha 甚至连那个paper 都不可以穿透，OK，你用 paper 就可以隔开它了。beta 你可以用3mm 厚的那个 aluminium 隔开它，如果是那个叫什么？gamma 你就要用 10 cm thick 的 lead，你要用到重金属才可以隔开它。OK，so 来，现在刚才我们讲了它的那个什么，so 它 can be stopped by a piece of paper, aluminium. OK，then、for gamma 是 by concrete or block of lead. So 它的 deflection by electric field，它 alpha 因为它是 positively charged，so 它会 deflected by negative plate。beta 是 negative charge，所以它会 deflected by positive plate。但是 positive charge 的意思，but gamma 因为它是 neutral，所以你用什么 charge 都不可能可以 deflect 掉它。OK，所以它不会 deflected。然后如果 by magnetic field 一样的道理，因为 electric field 它有加减，magnetic field 我们有 north 跟 south 也是加减的一种，so that's why alpha 跟 beta 都会 deflected by 这个 magnetic field，但是 gamma 因为它是 neutral，所以它是不会被 you will not deflected by negative field，any magnetic field，可以理解？嗯，alright，好，jot this down。 Now let me know. You always draw line tilted. Maybe you need to change the type of ruler that you use because I usually last time I usually use the heavier ruler. Heavier ruler then can I my line using line to draw will be okay. Maybe as well. Maybe the you have because the ruler if you use it for a long time, it will have those how to say corroded part where it will makes your drawing the drawing not so good, not so smooth. Okay. Yeah. This one is useless. Okay, this one is just okay. So this is how maybe you need to draw this one like okay. Now, for example, when we have a negatively charged plate here and a positively charged plate and a radioactive substance which release three alpha, gamma, and beta. So the alpha ray will be deflected towards the negative charge plate. Beta particle will be deflected towards the positive charge plate, while the gamma ray will go straight. Okay, so you just need to draw this. Okay. Okay, now let's continue. So the device that we can use to detect the radiative radiation, we have two, mainly got two types. We have a Geiger-Muller counter, okay, where there's a scanner, okay, there's a scanner like this, while or the using the film batch, or sometimes we call the photographic batch. Okay, these two are the one. All right, so you see, so different radioactive sources will produce different track in the cloud chamber. So this is a cloud chamber where we have a dry ice, a petri dish. Okay, inside the petri dish we have a black paper. Okay, and then we have an opening for light, and we put some alcohol on the felt strip, and we have a petri dish cover. So this whole thing we call the what you call cloud chamber. So when the radiative ray pass through the top part, so it will ionize the air molecule in the pathway. So the supersaturated alcohol vapor here, the vapor here, will condense on the ion to form the fine droplet of water, which can be seen on the white track. White track is what I call that. It didn't show here. It didn't show here because it should show up. There's a white color paper actually, because the water will left some trace, on the white paper. Okay, so the light will shine, the light shone that we shine to here will enable the track to be seen. So this is how the track looks like for alpha radiation. It's very consistent. Okay, beta looks like this. Okay, why? Because the energy is low already. Now for gamma, it's neutral, so you see it's randomized the movement. Okay, can you understand? Yeah. All right. Jot down whole thing, huh? Jot down whole thing. Okay. Can let me know, huh? Okay, so let's continue. So you see the source of radio ionizing radiation in the environment. We have a natural source like cosmic ray. Cosmic ray are the wave that the ionizing wave that we can found on what I call that on the whole universe. It's actually very how to say very uh interesting where when you use the normal what I call when you use the what I call that the radiation detector on the vacuum under vacuum, you still able to detect a value, and that belongs to the cosmic ray. Okay, and then we have some background radiation or the radiation that happen in the atmosphere. We call radon. Okay, and we have a solar ray and internal ray. Internal ray are those rays that how to say that will actually happen inside the what you call like us when we sit there although we have aircon, right, but when you go near your skin, you will find out that there's a heat dissipated out, right, that's part of the internal ray. Okay. Oh, I got mentioned here. Sorry. So radon is the one that the gas that diffuses out from the soil and rock, while the internal ray is produced naturally in the human body, like potassium isotope, all this. And for the man-made one, we have a nuclear. We have some what you call ionizing particle from nuclear accident, from nuclear test, from the use of radioisotope for medical purposes, and also some of the background radiation, man-made background radiation, like the radiation that we might feel in maybe the nuclear reactor, all this. Okay, due to the usage of radioactive isotope. Okay, all right. Now jot this down. For this one, radon and internal ray, if you don't understand, you can jot this down as well. Okay, now let's see. So the cosmic ray are the radiation that reach the Earth from space. So sometimes we also call it as a galactic cosmic ray. Okay, the cosmic ray are the radiation from space. Okay, so also called as galactic cosmic ray. So the rock in the soil, okay, normal one, contain the it has contain the naturally occurring radioactive substances like, for example, uranium 238, thorium 226, and potassium 40. Okay, these are the one the internal ray. And when the living things like plant, okay, the living things like for example plant will absorb the radioactive substance from the soil, and this pass through the food chain to our and then pass through the food chain to our body. So that's why when there is a what you call that we call when there is a when we say there is a we call the when there is a what you call that again the okay, when there is an animal eat the plant, for example, so the radioactive part will pass through the animal, and the animal will continue being pass to the next tier of food chain until human to human body. Okay, so the radioactivity also presence in the water, which is from underground and sea. Okay, and the radioactive gas radon is created when or when other naturally occurring animal undergo the radioactive decay. So means that it's created when other naturally occurring animal undergo radioactive decay. Because I'm trying to slim it down, but it seems like it's hard to slim down the. So a small fraction of background radiation comes from human activity. So these are the man-made source. So means that some of the part of the background radiation is from human activities. Okay, they are the man-made source. Okay, all right, jot this down. If you can reduce even further, then the better, because actually note is for you to read something easily. Okay, I'm going to turn over. Give me a second while you complete the note. Okay, so let's continue. So, like I said, for the cosmic ray, the high energy radiation produced outside the solar system or from other galaxy. Background radiation normally are released from natural sources or man-made sources. Hmm? All right. Now, okay. So now we have what I call the unit for the radiation. Radiation is called sievert. Sievert. Sorry. So the estimated dose of ionizing radiation, which is safe to human body, is like for building, normally it's 1.5 millisievert per year. Okay, then this is safe. Like 0.1 to 0.5 millisievert per year is safe as well. So more than others are more than that, okay, are considered dangerous. Okay, so now we are exposed to ionizing radiation source in the environment all the time, and this is called the background radiation. Okay, we call this as a background radiation. So the background radiation can come from natural or man-made source. So these are the one, okay, like we have a part of it come from soil and rock, part of it come from our body, the radiant gas from the mineral, food and drinks, and cosmic ray as well. Now, so let's see, like I said, the unit of dose rate measurement, okay, for background radiation. So the biological effect from radiation, ionizing radiation on human body, we measure in a quantity called dose. So dose for 1 sievert will be equivalent to 1 joule of ionizing radiation energy that is absorbed by 1 kilogram of living tissue. And for normal level, the background radiation or ionizing radiation is for less than 0.2 microsievert per hour is the normal level, or we call the safe level. And this radioactive radiation we can detect and measure by using the Gauge-Muller counter. Okay? You understand? Huh? So jot this down. You need to write. Yes, all of them. The highlighted one is actually the value that I want you to remember only. Okay, all of them.没有没有，是我不好意思的，对。其实我应该跟你弄了，其实这东西我在答应了，过因为我家里出一点问题，变成我没有办法马上就跟你做这东西。他们出图也好了，因为他 construction 的他可以给你改啊，通常也是他也是包在他们的那个 package 里面的。哦，你有打掉，没有打掉，这样子它是有些地方如果是打掉，它可能会需要你就是做那个drawing，然后来申请。他应该是要帮你申请那个 Majlis Perbandaran 啊，JKR 那边。哦，sorry，no，I'm talking to my friend. Oh, I forget to mute the mic. So sorry. I'm talking to my cousin. Yeah, this chapter you are gonna have quite something to memorize. All of them mostly theory. All right. Now, for background radiation or ionizing radiation, dose of less than 0.2 microsievert per hour is the normal level or safe level, like we have already just now mentioned here. So normally in terms of sometimes you need to jot down this one as well later, because sometimes they might ask you in terms of what you call the milli sievert per hour or even by year. Okay, so we have a X-ray, which is around, or food have, as long as there is a heat or you like the something that we cook, right? There will be a radiation of heat. So when there is a radiation, there is a radioactive. Okay, radioactive radiation doesn't necessarily from those only those that we have mentioned beforehand before this. Your heat as well sometimes also have. Just the value is very small enough to neglect it, something like that. So we have a X-ray, like around 5.5 millisievert per medical test. And then we have a smoking rate, the radiative radiation is around 55 millisievert per cigarette. Building itself will also emit the radiative radiation due to the concrete. We have 1.5 millisievert per year. Food radiation is around 0 to 0.1 to 0.5 millisievert per year. Environment background, 0.4 to 1.0 millisievert per year. Flight cosmic ray, pretty high, 0.003 millisievert per hour. You see, this one is by hour. If you convert to year, it actually quite high. Okay, high altitude cosmic ray, because high altitude, we are actually exposed easier to the cosmic ray. So the ray is a bit higher, 0.3 to 0.5 millisievert per year. From the outer space, which is the cosmic ray, is 0.35 millisievert per year. Okay, so you might need to jot down only this. This one only, just for your information only. Yes, just the science info. Okay, done. Okay, so let's continue. So normally the level of background radiation is normally very low and not harmful to human. So the unit to measure the background radiation dosage is by using the micro sievert per hour. So one sievert is equivalent to 1 joule of ionizing radiation absorbed by 1 kilogram of living tissue, just how we already mentioned. And the radiation that less than 0.2 microsievert per hour is normal or safe level. This one I already mentioned as well. Mm, okay, I think I will stop here for today. Okay, I think I will stop here for today. Your school now until which topic? Your school now until which topic?可以可以。你如果是讲你没有急着要我下去画图类，这样子我就不用讲，马上安排，因为我主要是要看我的那个 site。Okay, yours until when? The plant's transpiration. Oh, quite far away, Actually, it's far behind us, right? If I'm not mistaken, it's actually far behind us, Not just behind only, actually far behind, Okay. All right. Never mind. So, any questions before I let you dismiss? No. Okay, then we shall meet each other on next class. Bye bye.